Okay, this is a video key for the 10.3 and 10.4 review. So first one, solve for x. So I've got NP and NM are two congruent chords, so I know that their measure of their arcs are congruent as well. Or the measure of their arcs are equal, or their arcs are congruent as well. So I know that this is congruent to this, so I know that this is also 2x, and then I know 2x, 2x, and I know that this one is 144. The intercepted arc is 144, so if I add those all together, I know that equals 360, and I can solve for x. Equals 360, so that gives me 4x plus 144 equals 360, and then I'm going to subtract 144 from both sides, and I get 4x equals 216, and if I divide that by 4, I get x is equal to 54. Okay, next one. RZ equals 10, VT equals 5x, solve for x. So RZ, we can see that we have perpendicular, the distance between the center and this chord are the same. So that this distance between the center and the chord and the center and this chord are the same. So we know that the two chords are also congruent because their distances to the center are the same. And we also know that that distance to the center always hits at the midpoint, okay, because we had that theorem, or we had the thing that said that if you draw a line that perpendicularly bisects the chord, then it goes through the center. So if it's going through the center and is perpendicular, then it also has to bisect it. So I know that this has to be 10, and this is also 10, so that's total 20, and this is 5. This whole thing actually is 5x. So I know that 5x is equal to 20, divide by 5, and obviously x is equal to 4. Okay, number 3. A 24-inch chord is 5 inches from the circle's center. Find the diameter. So you can grab a compass and draw a perfect little circle if you want, but I'm just going to freehand a circle. Oh, look how great that is. Not really. Okay, so it says that a 24-inch chord. So I know I've got a chord of 24 inches is 5 inches from the circle center. So I'm just going to go down straight and call that 5, and then just draw a chord. Mark that perpendicular. And I'm going to say that, that full chord length is 24. That is 5. So I know that half of it, because since it's distance, again, it's going to be perpendicular. And if it's perpendicular and goes to the center, then it also has to bisect it, since we had the thing that said if you have a line that bisects it perpendicularly, that it goes through the center. So that's the only way we can have it go through the center and be perpendicular, is if it also bisects it. So then we want to find the radius. So really easy to find the radius because we've got a right triangle there. So our right triangle ends up being, we have the height, which is the distance from the center to the chord, as 5, and then half the chord is 12. So we can easily find out that the hypotenuse is 13. That is a known Pythagorean triple, and you can work it out. 12 squared plus 5 squared equals c squared, or I should really say r squared, since that's the radius. And we're actually not just trying to find a radius, we're finding diameter. I was wrong. So it'd be 169 equals r squared, square root, r is equal to 13. And then since that's the radius, we know that the diameter is double that. So the diameter is 26, and don't forget your label, inches. Moving on to number 4. Find the value of the variables. Okay, so we've got some other business going on, so you need to know the vocab in order to do these well. So this angle right here is our inscribed angle because its vertex is on the circle and its sides are chords of the circle. Okay, and then its intercepted arc here, we are told that it's 100 degrees. So obviously y is equal to 100 because this this angle right here is that intercepted arc. So that's y degrees, it's 100. And then we know that if you have an inscribed angle, it is half of the intercepted arc. So we know that x is equal to 50. Moving on, number 5. We have a quadrilateral inscribed inside a circle. And we learned that opposite angles are supplementary. So pretty easy. The measure of angle D will be supplementary with 72 degrees. So we know that's going to be measure of angle D is 108 degrees. And the measure of angle E is going to be supplementary with 98 degrees. So that's going to be 100, I'm sorry, it is going to be 82 degrees. So really all these problems, you just have to know like the facts and the vocab. The math is not hard. Okay, find the value of x. So notice that we have one diameter and then we have a chord. So the importance of that diameter here is that this is going to be a semicircle here, okay? And we know that this inscribed angle here is 23 degrees, so its intercepted arc's measure, so that would be, if I drew this guy here, this intercepted arc measure will be double that. So this is going to be 46 degrees. And then I know this whole thing is a semicircle because its endpoints are on a diameter. And so that I know that x plus 46 has to equal half of a circle, which is 180 degrees. So all I have to do is subtract 46 from both sides, and I get 134 is equal to x. X is 134 degrees. Moving on to number 7. We've got some chords and business going on here. So notice that we've got 2 inscribed angles. Okay, so this first inscribed angle has endpoints here and here for the side length, for its sides. And then same thing for this inscribed angle, has the same endpoints for the sides on the circle, okay? So remember, when that happens, I talked about how if I moved this anywhere and kept these 2 as endpoints to the sides of the circle, the angle would be the same. So I know those 2 angles are congruent. So I know that x plus 35 is equal to 3x minus 7. So I'm going to subtract x and at the same time add 7 to both sides. So I get 42 equals 2x divided by 2. So x is equal to 21. But that's not all, folks. I also have to find y. So y is going to be the measure of this arc here. And notice that it's the intercepted arc of both of them. Okay, since they had those same endpoints for one side of each side of the angle, those are going to be, this is going to be the same intercepted arc, and that is always double the inscribed angle. But we don't know the inscribed angle, so don't think about doubling this guy. We have to find the inscribed angle first by plugging it back in. And you know the easiest one to plug this back into is the x plus 35. So 21 plus 35 gives us 56 degrees. So that's the inscribed angle. So y is double the inscribed angle. So y is 112 degrees. And this time you really do have to put degrees. On all those other ones that already have degrees, technically we shouldn't have to put it. Here we do because it just says y. So we need 112 degrees on this one because it's the measure of an arc, which is in degrees. Number 8. We have a triangle inscribed here, okay? So we have that inscribed angle right here, but I don't know if this is the right triangle, guys. I just don't know. Oh, wait, yes, I do, because this is an inscribed angle. Okay, we don't know its measurements, but its intercepted arc, okay, the intercepted arc, remember, is wherever its endpoints are. The arc that's formed there, with the endpoints on the circle for the inscribed angle, is a semicircle. So whenever that happens, and again, you can also go back to the, it's half business. It's going to be half of that, so that is a 90-degree angle. because its intercepted arc is a semicircle. So I can easily figure out x by knowing, by just knowing that that's a 90-degree angle. So these sum to 90. They're complementary. So x is equal to 63 because 63 plus 27 gives us 90. All right, from there, I've got some other fun things I can do. So since I know x is 63 degrees, if you look at this inscribed angle, okay, these are 3 inscribed angles. But if we look at this one, its intercepted arc is this guy here, okay? And so that's z. That's the measure of that arc is z. So it's always going to be the intercepted arc is double the measure of the inscribed angle. So since this is 63, z is going to be double that. So z is 126. And then the last one is the same idea, but the inscribed angle this time is the 27 degrees. So its intercepted arc is this guy. And again, that's the angle measure, so it's going to be double the inscribed angle for the intercepted arc. So 27 times 2 gives us 54. So y is equal to 54. Those are our 3 answers for number 8. Number 9, regular hexagon ABCDEF is inscribed in a circle. What is the measure of arc CE? So this is a regular figure. So you can draw this. This is just going to be awful. I don't know why they couldn't just draw it for me. I'm just going to try one more time because I'm like sitting at an awkward angle here. All right, I got to sit up. All right. Good enough. And then you need a regular hexagon. So again, this is going to be terrible. Okay, so with a regular hexagon, we know that all those angles measures have to be 60 degrees. The interior angles of the hexagon anyway. And we know that the interior, oops, somehow my color got changed. And we know that the interior angle of the hexagon will be the measure of the arcs. Okay, that turned out beautifully. Okay, so there's the center. So we know that if I drew, all the lines to the center, since it's a regular hexagon, we know we can find the measure of the central angle by taking if it's regular, taking the number of sides, 360 divided by the number of sides. And so these would be 60 degrees. So since this is 60 degrees, that's the arc measure. So all of these arc measures are 60 degrees. Now, if you look at naming this, so we got to name it A, B, C, D, E, F. And the question was, what is the measure of arc CE? So CE, remember, oops, I didn't get the line here. That when we're talking about arcs and they're named with 2 letters, that we're always looking at the minor arc. So that'd be from C to E this way. So we want to know what's the measure of this arc here? Well, that's just 2 60-degree arcs, so that's going to be 120 degrees. That's the measure of arc CE. And that's it for your review worksheet for 10.3 and 10.4.